So, the next thing we got to look at is regression. Regression sounds like something bad, like you're losing skills, you're going backwards, but in fact, regression is good. Regression is how we use X to predict Y. Remember the ice cream man? He wants to be able to predict how much ice cream he's going to sell each day. And he wants to use weather to do it. Y equals, remember this from an algebra class? Y equals mx plus b. M is your slope. B is your y-intercept. If this sounds like a foreign language, you might want to go back to your algebra book. So, if the correlation coefficient shows that you have a relationship between x and y, then you can find the equation of a line like this that relates x and y. How? Once again, we're going to let the computer do that. So let's say the ice cream guy measures the temperature and how much ice cream he sells. And he puts the data into a computer and finds the equation of the regression line. It might look something like this. Why is Y wearing a hat? Y is wearing a hat again. The hat is because this is a predicted value. The actual amount of ice cream he sells might not be exactly what's predicted. So which one should be X and which one should be Y? Yes, temperature should be X, ice cream should be Y. It doesn't get hot out because more people eat ice cream off of his stand tomorrow. If you could make it hot by selling ice cream, or make it cooler by not selling ice cream, that would be pretty cool. But that's not how it works. So, X is the temperature in degrees Fahrenheit. Y is pounds of ice cream sold. So, we're finally going to do some math. Roll up your sleeves, because this isn't going to be very hard at all. I want you to predict how much ice cream this man will sell on a day when the temperature is 85 degrees Fahrenheit. Well, we have an equation. All we got to do is plug it in. So you plug it in. Remember order of operations. Multiply first, then add. You got it? Good. So, on a day when the temperature hits 85 degrees, he can expect to sell about 24 pounds of ice cream. So, This is the only actual calculation that you're going to be doing in Chapter 9. And if you're having difficulty with this, then yeah. Let's do one more example. So let's say X is the number of hours you study and Y is your grade on a test. Hopefully, there is a positive correlation between these two things. So let's say I take a bunch of students and I anonymously measure how many hours they study plus their grade on the test. Why anonymously? Because if it's not anonymous, people will lie. And I find there is a positive relationship, and the formula is 3.15x plus 52.7. Predict the grade of a student who studies for 8 hours. It's a pretty hard test. I got 77.9. How about you? So, a student who studies for 8 hours for this very difficult test will get a grade of 77.9%. Now, this plugging in, it's pretty easy, right? There's just one thing you've got to be careful of. You can't always use the regression equation. There are two things that you have to check before you can use the regression equation to make predictions. The first one is you have to make sure that R is reasonably strong. One of the things that R measures is how much Y depends on X. Let's say I go to Walmart every week for a year and I count the fraction of shirts for sale that are red and the price of potatoes. So I've got these two things that presumably have nothing to do with one another. But I can go out and collect data and find the equation of a regression line. Should I use the popularity of red shirts to predict the price of potatoes? I can make an equation to do it, but that would be a stupid thing to do because they don't have anything to do with one another. So, if you're going to use the regression line, make sure that your R is strong. If R is weak, the equation is useless. How strong? Pretty much anywhere below 0.4 or above negative 0.4, the regression equation is a waste of your time. The second thing is you have to use appropriate X values. And appropriate means close to the ones in your original data. If the ice cream man measures the relationship between temperature and ice cream sales in the summer, his equation might not work when it's 20 degrees out. Study and test grade. Let's say that this was only students who studied somewhere between 5 and 20 hours. This might not work on someone who didn't study at all. And it might also not work on somebody who studied 50 hours, because the best grade you can get is 100. If you generated your equation using children, you shouldn't try to apply it to adults, and vice versa. Back at the beginning of our talk on regression, we looked at age versus income, that as you get older, your income tends to go up. Should I use this equation to predict the income of someone who is 80 years old? No, because most 80-year-olds are retired. So, before you trust your regression equation, make sure that R is reasonably strong and your X value that you're trying to plug in is appropriate.